Good morning, dear students. I am Sanchit Kalra, and today we'll continue with our chapter that is chemical effects of electric current. In the previous session, we have discussed about some basic points of this chapter, like what is electricity, electric current, electric charges, and their flow. We have understood their flow with the help of a circuit diagram, uh, the flow of electric current and flow of electrons. Uh, in that, we have also discussed about some symbols of like open circuit, closed circuit, and everything else. After that, we have discussed about conductors and insulators, and we have also talked about why conductors conduct electricity or allow the passage of electric current through them. So we have discussed all this in the previous session. From today's session, we'll discuss about some major concepts that this chapter deals about. So let's start with our first concept, that is good conductors and bad conductors. Okay, so before that, let's try to understand what makes the conductor allow electric current to pass through them. So these are some delocalized electrons that helps the conductor to allow electric current to pass through them. Okay, so basically the conductivity of conductors is due to the delocalized electrons. Similarly, in insulators, they have a very few or don't have delocalized electrons. But in nature, we don't consider substances as insulator and conductors. We classify them as good conductors or bad conductors. So good conductors are those substances which allow complete flow of electricity through them, like metals, gold, silver, etc., iron, copper, etc. Similarly, those substances which allow a little, very small amount of electricity to pass through them, we consider those substances as poor conductors of electricity. For the sake of example, let's try to understand an example of air. Okay, in general cases, air is a bad conductor of electricity. So normally air doesn't conduct electricity and acts as an insulator or bad conductor. But just like everything else in nature, it has a limit. Okay, so if the voltage rises beyond a certain limit, so a phenomena occurs, which we term as insulation breakdown. Okay, and the air start conducting. So when this air start conducting, the sparking occurs. And in this breakdown phenomena, the electrons of a bad conductor start to move to a very high electric field, and this is which results in conducting electricity. So I hope you understood why bad conductors in certain situation conducts electricity. So this is the reason behind them. So I have also drawn two figures here. In first case, we put a key. So key is a good conductor made up of any metal, and wood is a bad conductor, but it allow a passage of electric current. Similarly, as I have discussed the phenomena of air, we can also put wood in case of air. So this pencil in case of air. Okay, now coming to our next part, that is, I have mentioned here some examples of conductors and insulators. So I have also mentioned previously silver, gold, copper. These are good conductors of electricity. And bad conductors, as you all know, rubber, glass, oil, diamond. These are some bad conductors. I have also mentioned some other examples, like silver is a good conductor, copper, aluminium, brass, iron, lead, and mercury, and glass, asbestos, wood, water, coke, cotton wool, air. These are some bad conductors of electricity. Next, coming to the major part of this chapter, that is the important differences in the conduction of electricity by solids and liquids. Okay, so what are these differences? So as we all know that in solids, the electricity is carried by electrons. For the sake of example, let's take an example of gold or silver. In gold, the electricity is carried by free electron or delocalized electron, as we say in case of key. But in case of liquids, the electricity is carried by some ions. Okay, these ions are basically the ions are basically of two charges, the positive charge and negative charge. Uh, these ions are these ions basically all allow the electric current to pass through them. With the help of these ions, electricity is carried in the liquid. And then in solids, when electricity is passed through solid, no chemical change take place. But when electricity pass through liquid, the chemical change takes place. Let's take an example of water. When water is decomposed through electric spark method, it decomposed into hydrogen and oxygen. So the chemical change takes place in that, because new substances formed. In physical change, no new substances formed, but in chemical change, as you know, new substances are formed. Like water is decomposed into its constituents, hydrogen and oxygen. So in liquids, the electricity is passed through positive and negatively charged ion and through liquids. So the chemical change which takes, that is the chemical change takes place in liquid, but in solids the chemical change do not takes place. Okay, and those substances, those liquids which conduct electricity, we term them as conducting liquids, and the chemical change which takes place in these conducting liquids on passing the electric current, that phenomena is termed as chemical effect of electric current. So we derived our topic, that is chemical effect of electric current. Now coming to one major topic of this chapter, that is electrolysis. Before understanding what electrolysis is, let's try to understand what an ionic compound is. As I have told you earlier, in liquids the electricity is passed with the help of carried with the help of some positively and negatively charged ion. So these positively and negatively charged ion, when held together, form a compound. That compound is known as ionic compound. That compound is held together by some force, and that force is known as electrostatic force. I hope you guys are able to understand what I am trying to explain you here. Now, what is electrolysis? So, ionic compound. For the sake of convenience, let's take an example of NaCl. NaCl is an ionic compound. Okay, these NaCl is formed by positive ion Na positive and negative ion Cl negative. When these two ions combine and held together by an electrostatic force, they form a compound NaCl. NaCl is basically a table salt that we consume daily. So for the sake of convenience, we put NaCl over here in place of ionic compound. Okay. So ionic compound conduct electricity when their ions are free to move. So NaCl is able to conduct electricity when Na positive and Cl negative. Cl negative. Na positive is positively charged ion. Cl negative is negatively charged ion. When they are free to move, they will conduct electricity. Okay. And these ions move in liquid state or in aqueous solution. Liquid state or aqueous solution, the difference is, in liquid state you can say take any example of any liquid, okay, but in aqueous state the solute should be the solvent should be water. Okay, solute, that is in less amount, solvent, that is in excess amount. The substance that you are dissolving in a liquid, that substance that you are dissolving should be considered as solute, and the liquid should be solvent. And when the liquid is water, that is a aqueous solution. The final compound will be formed, will be a aqueous solution. Okay, so the molten and dissolved substance, the substance that is molten or dissolved, we term that substance as electrolyte. So electrolysis is basically the decomposition of electrolyte by an electric current. Let's take an example. So take an example of NaCl. We have this diagram over here. So let's take the example of NaCl. We dissolved NaCl in water. Okay, when electric current is passed through that, on application of electric current, the Na positive and Cl negative ions will dissociate. The positively charged ion and negatively charged ions will dissociate, and this dissociation, when this dissociation occurs, the Na positive NaCl is an electrolyte, and when with the passage of electric current, when this dissociation occurs, that phenomena is known as electrolysis. Okay, so the effect in which components of a compound get split due to the passage of electric current, that phenomena, that process is termed as electrolysis. Okay, and this arrangement of two electrodes, these are two electrodes, cathode and anode. I'll explain what are electrodes, cations and ions in the coming slide. So this arrangement of these two electrodes kept in a conducting liquid, this water or some liquid, another liquid, in a vessel. This vessel, we say this as electrolytic cell. So what is an electrolytic cell? An electrolytic cell which have two electrodes and kept in a conducting liquid in a vessel, that is known as electrolytic cell. So coming to our next topic, that is electrodes. So what are these electrodes? So this positively charged electrode is termed as anode, and this negatively charged electrode is termed as cathode. So an electrode is basically a conductor of electricity, which can carry electric current into non-metals and other poor conductors of electricity. So when we term this positively charged electrode, so the positive ions that it has are also termed as cations, and this negatively charged ions are termed as anions. So the positively charged electrode will be known as anode, negatively charged electrode will be cathode, positively charged ion will be cations, negatively charged ions will be anions. Okay, so the electrons leave the cell through anode and enters the cell through cathode, and these during electrolysis the positive ions, that is these cations, move to the cathode, and this negative ions move to the anode. This positive will move to the cathode, that positively charged ion will move to the cathode, and negatively charged ions will move to the anode. Cations will move to cathode and anions will move to anode. Now, the next topic is electrolyte. So electrolyte is basically, we have previously also discussed about this electrolyte. So electrolyte is basically a substance that conducts electric current as a result of dissociation into positive and negative charged particles like ions, which are known as ions. Like we took the example of NaCl, that is table salt. So table salt dissociates into Na positive and Cl negative when electric current is passed through them. That phenomena when electric current pass through that and that dissociates is known as electrolysis, and that with substance which dissociates is termed as electrolyte into positive and negatively charged particles. The positively charged will be known as cations and negatively charged will be known as anions. I hope you understood this. So your homework is you have to take a look at this electrolyte, and you have to write at least five examples of each strong electrolyte, weak electrolyte, and non-electrolytes. Now coming to our next topic, that is, do liquids conduct electricity? We have talked about everything. Solids conduct electricity. We have also talked like liquid conduct electricity, how they conduct electricity. So let's talk in general. Do all the liquids conduct electricity? So not all the liquid conduct electricity, but some of them can be regarded as good conductors. Other are bad conductor, like we have talked good conductors and bad conductors. All liquid can't conduct electricity, but some of them can be regarded as good conductor. So when salts are dissolved in water, like NaCl is dissolved in water, so it conducts electricity. It will act as a good conductor of electricity. But distilled water, which do not have salts in it, will not conduct electricity. So here I have mentioned some of the examples which are good and bad conductors of electricity. Like distilled water, this does not have salts in it, so it is a poor conductor of electricity. Tap water, it have salts, minerals in it, so it is a good conductor of electricity. Lemon juice, citric acid conducts electricity. Vinegar do not conduct electricity, poor conductor. Cooking oils, similarly, these are examples you can read from here. Okay, now our next topic is if they conduct electricity. We have talked not all of them conduct electricity, but some of them conduct electricity. So if some of them, let's say some of them conduct electricity, so how do they conduct electricity? Let's try to understand that. So when different substances are mixed in water and electricity is passed through them, so that will break those compounds. The electrolysis phenomena will take place, and the positive and negatively charged ions will be dissociated, as we have learned and understood in electrolysis part. So when the electric current is passed through them, these ions will carry the electricity with them through positive to negative, negative to positive, like we have understood in case of electrodes and electrolysis. So this is how liquids conduct electricity. Basically, electric current is passed through the liquid. The ionic compound will dissociate, break down into positive and negatively charged ions. These positively and negatively charged ion will then carry electricity through it. So I hope you understood what we learned in today's session, and I hope that you will study well. Uh, that is all for my end for today's session. We'll discuss the next topic in upcoming session. I hope you'll stay safe and stay happy and do study at home. Thank you and have a nice day.